We have already implemented the joystick UI design. But after running, the joystick has no effect when touched. This lesson. Let's first realize the function of the left rocker touch. Because the touch function of the left joystick is realized, touch function of the right joystick, basically similar. In the scripts folder, new build. Joystick controller TS file. Press Fr, Ctrl加C to copy the file name. Then double-click to open. Change the class name to be the same as the file name, Ctrl plus V. Ctrl plus S to save. Then go back to the scene editor. Find the joystick node on the left. Window inspected on the right. Select Type Script. Find the joystick controller custom script for control. Or go to the joystick UI. Ctrl plus S to save. In order to increase the flexibility and comfort of user control, we use a drag and drop control joystick. For smoother control after releasing the rocker cap, the rocker cap should automatically return. But if we add event listeners to the rocker cap, because the rocker cap is smaller, the convenience of user control will be slightly insufficient. So what we're doing is we're giving the joystick node add event listening. When touched on the joystick, immediately adjust the rocker cap to touch location. Drag and drop can adjust the position of the rocker cap in real time. After releasing, the rocker cap returns to its original position. That's where the center of the joystick is. Through analysis, we are in the script. Be sure to add event monitoring to the joystick to update in real time position of rocker cap, so add in the joystick controller TS script. Set the rocker name and rocker cap name respectively. These two properties allow users to edit through the editor. Follow-up convenience. The joystick UI can be replaced when necessary. This name. It is recommended that you obtain it from the joystick UI. Press FR, then press Ctrl and C to copy. Left and right joysticks. It's actually a picture. Therefore, you need to add the picture of the left joystick and a property of the left rocker cap picture. Because of these two properties is when the program starts. Obtained by rocker name and rocker cap name. So just set it to private. Private properties are recommended to start with an underscore when naming. To control the joystick, get the joystick UI components first. So add the uComponent private property. Ctrl plus S to save. In the onStart method, via UI object game object, get the uComponent on it. To get the component of this uComponent, because here, it uses a joystick UI we designed. Because of the onStart method, it is generally used to initialize the value of some variables. Do some game initialization and loading operations. Then get the canvas through the component of uComponent. Through the canvas, find subnodes of image type by name. Then add event listeners to the left joystick. For realizing touch function, in the future, there is a joystick on the right side that also needs to be added. Add event monitoring to the joystick. Start enable event listening. This method does not have. We can click and let him create one. The return value is void. No return value required. What events are mainly monitored here? What about the classmates who just got into contact with our engine? You can go through our official website. Find the API. Then search here. Click. Find events related to joysticks. We just analyzed. This event point-up represents the event when the pointer is raised. When the user presses and releases the mouse button. Occurs when touched. Can be used to restore rocker cap position upon release. Event point drag. This event can be used when the rocker cap is dragged. Real-time update of rocker cap position. This event can be used when touching on the joystick. Adjust the rocker cap to the touch position. So we add these three events to the left joystick. Event type control. The control event we just searched for. Point and event point up. Point drag is drag event. Then when the drag event occurs, the function needs to be called back. This callback function is updated in real time. A position on the left rocker cap. Then let's write a method. This left joystick cap is a rocker cap. Let it go. Then click Create a method. Return void. No return value. We'll finish this plan later. Okay, again, this is drag. Another is when we release the rocker cap to restore its position. In addition, when touching the rocker cap, when touching the joystick, to update the position of the rocker cap to the touch position. There are 2 more events, copy 1. One is another one is event point up. This is not to update the position of the rocker cap. When it is released, restore its position. Let's write another method. Write a method for location restoration. Because if it recovers left rocker cap and right rocker cap, they are all rocker caps. Put it in the first limb position, so the 2 of them can share the same method. We don't need to divide the method of restoring the left and right rocker caps. OK, click. Declare a method. Good key code. It is recommended that you develop the habit of writing notes. This is the location of the recovery rocker cap. Of course, we could write one in here. Debug, log. This is a real-time update of the position of the rocker cap. This is a rocker cap restoration. Let's test it out first. Is the added listening in effect? 3 events. Then click on the console. Clear this place first. Run. Finally click here. Real-time update of rocker cap position. When I click on this periphery, it means it has been triggered. Then drag again. Drag and drop real-time updates, yes. And then there's restoration. The position of the recovery rocker cap is also available. Here we go. We need to achieve the movement of the rocker cap. Here, it will be difficult for some students. I hope you all have a 12-point spirit, because it involves the transformation of the coordinate system, operation of some vectors. In order to make it easier for everyone to understand, I drew a few pictures beforehand. Look at this picture. If during operation, drag the left rocker cap to the position of the middle point of the white arrow, we're going to put the rocker cap update to this location in real time. How are the coordinates of this location calculated? Some students say it's not easy. That's where the mouse is touching. But there's a catch. Our mouse touch is to touch the entire screen. Can be touched. So of course, the position touched by the mouse is the obtained world coordinates. That is, the coordinates relative to the upper left corner of the screen. The red axis in the diagram. That is world coordinates. Because the upper left corner of the screen is the coordinate origin of the world coordinates. So where the mouse touches, it can be understood as the vector represented by the white arrow. But are the coordinates of our rocker cap world coordinates? No. It's a local coordinate. A classmate remembered when we designed the joystick before. Left rocker cap is the sub-node of the left joystick. So, default left rocker cap coordinate origin is the center position of the left rocker. That is, in the picture, the origin of the green coordinate system. The position where you drag the rocker cap, it's actually the purple vector. So we find the purple vector. How to calculate the purple vector? Obviously, it's just the white vector minus the blue vector. White vector, it is an event coordinate that we get by touching. So here's the crux of the matter. How to find the blue vector? Some students believe that it's the coordinates of the left rocker cap. If you think so, that proves that the last class was not serious enough. Take a look. Our left rocker cap. Left rocker cap, where is its anchor? Is it the lower left corner of the screen? When it is 0, 0. If it is the coordinates of the left rocker cap, If it is based on world coordinates, it should be at this point. But it is based on the lower left corner of the screen as the coordinate origin. Remember when adjusting the left rocker cat position, talk about the left joystick. Does one of its anchors point somewhere? Lower left corner of the screen. Yeah, it's in the lower left corner of the screen. When we set the x and y coordinates of the left joystick, when all are 0, it coincides with the lower left corner of the screen. Is it the lower left corner of the left rocker cap? The lower left corner of the coordinate coincides with the lower left corner of the screen, not the center of the joystick, right? It's not the center of this joystick. Coincidence the lower left corner of the screen. So there's a problem here. So, when the set left rocker anchor point is the lower left corner, the coordinates of the left joystick here are the relative coordinates. It shows the lower left corner of the left rocker relative to a coordinate in the lower left corner of the screen. After this coordinate is converted to world coordinates, you can use the second picture, orange vector, to represent this one. This is what you just saw. These values. This 100到100. What does this value that you see represent? It means the starting point of this yellow vector relative to a vector in the lower left corner of this screen. This relative coordinate is converted to world coordinates. You can get the left joystick. A vector transfer object for this blue rectangle. Then get its word position. It's packaged in the engine. Look at the second picture. Blue vector required. Isn't it equal to orange vector plus yellow vector? Yellow vector is not simple. This yellow vector, as long as you know the radius of the left joystick, comes out. So write code to implement some core functions. The point is to understand the principle first. Do not understand the principle if you want to modify it later. You get a little headache. Below, to make it easier for everyone to understand, we'll just take this schematic. Use the texture tool to paste it on the screen. Then let's write this code together. First, we are in the onStart method. Initialize some fixed values. For example, the radius of this joystick. It's fixed. And the center point of the left rocker. That left rocker cap. The original coordinates of this center point is always fixed. Add to properties first. It's a two-dimensional vector. Number type. Then add it to the onStart method. Initialize these values before listening. Okay, one thing to keep in mind here. Our left rocker. You can get the sub node through this canvas. But this left rocker cap. One of his hierarchical relationships. Yes, do this. This left rocker cap. Its parent node is the left joystick. So it can only pass. Get it through this. Get sub node. Now we need to calculate original coordinates of the left rocker cap. That's the cross-center dot of this green coordinate system. Original coordinates of the left rocker cap. It's actually the coordinates of the center point of the left joystick. It's the midpoint coordinate indicated by the yellow arrow. Because it never changes, we can use the const declaration, a constant. Transform object. Get one of his transform objects first. It's the blue rectangle. After the transform object is obtained, we take the width of the blue rectangle and divide it by 2. Can get its radius. It's equivalent to this yellow vector. You can ask for it. This is the radius we're going to use. It has a width inside divide by r, because its height and width are the same. Then calculate its original coordinates. This original coordinate is equal to this orange vector. Add the yellow vector. The orange vector is inside this joystick rect transform. It has a word position. You can use this object too. It's this blue rectangle. You can get its world coordinates. You get an orange vector. After getting the orange vector, is it equivalent to adding a yellow vector to get a blue vector? The yellow vector is the offset. Is that equivalent to this thing? That is, it is tilted to the upper right, that is, the x direction is positive. Tilt up. So the y direction is negative. Then we can declare an offset. Offset vector. This is a binary vector. New. Vector 2. That's the value. Offset in the positive x direction. The y-axis is negative. Y-axis negative direction. Just add this offset. Translation vector. Offset is the yellow vector. In that case, you can calculate one of the endpoints of this yellow vector. You get this blue vector. The blue vector knows. We can calculate this purple vector. A vector of world coordinates of a touch point with the mouse. Subtract the blue vector. In fact, at this location, that's the blue vector. Finally, the method of completing the joystick movement. The first step is to obtain the drag and drop coordinates in the GUI. The second step is to calculate the coordinates of the rocker cap. The third step is to update the position of the rocker cap. The GUI is an object encapsulated in our game engine. Where to get it from? When dragging, you can get the data in it. Then get the drag and drop coordinates. Define a variable. It is a two-dimensional vector r. Via event data. A drag and drop data point position just obtained. There are coordinates in it. That's where we are. Is the coordinates of the end point of this white vector. The world coordinates. You can think of it as finding this white vector. Well, after knowing the white vector, the last step was in this place just now. This one actually computes the blue vector. We can take this white vector and subtract it from the blue vector. You get this purple vector. You can calculate an offset coordinate of the rocker cap. After that, just fix it. Okay, calculate the coordinates of the rocker cap. What about the rocker cap coordinates? We declare a variable left joystick cap position. Coordinates of the rocker cap. It is a two-dimensional vector r. Equal to drag and drop coordinates. This is the white vector. Subtract. subtract the original coordinates of a joystick calculated above. Since the original coordinates are always unchanged, in this case it actually counts as a purple vector. Then put this value. Who is it set for? Set to this rocker cap. Here, one more thing to note. Because if you set it, this is a local coordinate. Why main local coordinates? Because of the position of this rocker cap relative to the position of its parent node. So we're going to use local position instead of using world coordinates. However, there is one more point that you need to pay attention to. It's just that you can't drag this rocker cap indefinitely away. You see, drag to this position, it's actually beyond that. What should I do with it? It definitely won't work if you drag it to this position. It should be pulled to this position. And that's where we have to pull it back. Remember when we talked about math problems before? Is there a vector normalization? When you normalize it, what does it become? Becomes a vector of length e. What else needs to be done after normalization? You also need to multiply by this radius. It was originally in this position after normalization. By radius, it is pulled to the edge of this joystick. Therefore, before updating the location, process this value. Can't go beyond a certain range. Just like Taiwan, although it's a bit frustrating now. However, we cannot break through the bottom line of one China. This bottom line, it's actually the circle around the joystick. Therefore, we have to limit the range of movement of the rocker cap. That is, what is the maximum distance that the rocker cap can move? Do you need to be before the third step? Do restrictive treatment if the joystick vector calculated in the second step. And that's how it works. The purple vector in the figure, when the purple vector length is purple. When the length exceeds this radius, we need to retract it back to the left joystick. Above a circle of. I just drew a picture. What's the radius of the purple vector? Isn't that what the radius is? When you go beyond this paragraph, do you want to retract it? Retraction is what the vector does. To move it to this position, move to this location, you need to first normalize the vector. After vector normalization, it may be at this position. And then what do I do? Multiply it by a radius. Just zoom in. Just to this location. Pre-vector normalization. Multiply him by a radius of the joystick. You can also try it first. What happens when we don't write? Let's run it first. It can be towed here. But it can be dragged indefinitely. That's definitely not possible. It doesn't meet the needs, right? In addition, the recovery method of the rocker cap has not been written yet. I'm going to solve this problem here. You'll notice that when we click on the rocker cap, it doesn't trigger. You see, clicking the rocker cap does not trigger. We need to set up. Check one of the ray projection coordinates of the rocker cap. Go back to the place where you want to press the UI. Click on the left. There's a ray projection coordinate in there. Come see this place. Ray projection coordinates. We need to remove the ray projection coordinates of the rocker cap. Indicates that the rocker cap does not receive ray projection. Equivalent to when it can be understood as event projection. The rocker cap is transparent. We need the whole joystick to trigger. So put this. Click on it to remove this. This one. This shows the left rocker cap. Remove it. Because it doesn't matter when you touch it. That's the equivalent of it. You see it as transparent. In fact, it will be triggered when I click the joystick area. It doesn't mean that the rocker cap will trigger. And look at the joystick. Check this box. Press the Ctrl+S key, remember to save. And we'll run it again. Look at this, which position to click. Where will this rocker cap be positioned? Then we drag and find. It definitely won't work if it's dragged out. Max, where do we only allow him to be? Only allowed within this range. Of course, when I changed it just now, remember to change the rocker cap on the right as well. For the right rocker cap, remove this. That right joystick. Check this box. Press Ctrl+S and save it. So let's do a restrictive treatment. Limit its maximum range of movement. What if it was this? Its value is greater than this radius. That means the purple vector. Beyond a radius of this left rocker. Beyond the radius of the left joystick, we need to normalize it first. Then multiply it by one of its radii. Normalized equivalent normalized point. Multiply it by one of its radii. But this place, I suggest you do one more thing. Because I said everything. Whenever you need vector normalization, then we need to consider whether this vector is 0. Because this place has to be larger than this radius, that's definitely not 0, so this place can be used without judgment. Here it is. If his die length is greater than this radius, it needs to be normalized. So it can't be a zero vector. So no need to write be special in this place. Run. You will find that it can't be dragged out. Did it only move within a limited range? But you will find that when I release the mouse, the player also needs to manually drag it back. It can't be reasonable. So when we release it, we automatically return to the origin. There's another way we need to finish. It's the way to reset the joystick. The way to reset the rocker is quite simple. Is it equivalent to setting it to the 0 position? Take a look at this location, this place. When we set up the joystick UI, like I'll pull it out. I drag it out. Now you see? I change this to 0 on the right and it will reset. Change these to 0 and it will reset to the origin. Because it's a local coordinate. Local position, is it a local coordinate of it? Just change it to 0. Okay, this is fairly straightforward. Then add everyone if you want to save trouble. You can bring this over. Copy. Paste. Save it and run it. I'll drag it again. Release automatically returns to 0. And I was in this place. You don't have to order the rocker cap. You can also click the joystick, pull this rocker cap into this position. Release back. You see, drag it over here. Can you drag it out? Can't drag it out. So limit his range of movement. That's the touch of the joystick. So far, we've finished touching the left joystick. Touch of the right joystick. I believe you should be able to do it yourself. Next class, let's implement the left joystick. Control player movement. You can think about it beforehand.